This video is going to show you how to use log properties to find the exact value using a table of values. So first, let's recap our log properties. Remember that if I have log AB, which is multiplication, it can be log A plus log B. Those are equivalent. If I have log A divided by B, it can be written log A minus log B. If I have log A to the B power, that can be written as B times the log of A. So those are the three properties that we'll use in this video. Given the table below, use the properties of logs to evaluate each of the expressions listed for A through, we're going to do just D right now. So we're going to start with log 20. So I want to see, using my x values only, so only the ones that they give me, 2, 4, 5, 8, and 10, how can I rewrite 20? There are actually two different ways, and I will do it both ways. So I can rewrite 20 as 4 times 5. So instead of log 20, I have log 4 times 5. And our rule for multiplication means to add. So this is log 4 plus log 5. Now, according to my table, log 4 is equal to 0.6021, and log 5 is equal to 0.6990. So now I can go to my calculator and type those in. 0.6021 plus 0.6990. And there's my answer, 1.3011. So I said there were two ways. Instead of using 4 times 5, you could also use 2 times 10. So this would be log 2 times 10, which would be log 2 plus log 10. According to the table, log 2 is 0.3010, and according to the table, log 10 is 1. When I add those together, 1.3010. So slightly different answers, but just based on the rounding. But as long as you're using the table, that gets you full credit regardless of which way you do it. Let's take a look at part B. Log of 5 halves, or 5 divided by 2. So if I'm dividing, I subtract. So I have log 5 minus log 2. Log 5, according to the table, is 0.6990, and log 2, 0.3010. When I go to my calculator and type those in, 0.6990 minus 0.3010, we get 0.398. And that's it. Let's take a look at part C, log of 25. So log of 25 can be written as 5 squared. And then my power rule tells me that I can take my exponent and bring it to the front. So this is really 2 times log 5. According to my table, log 5 is 0.6990. So 2 times 0.6990 will give me 1.398, which is the answer. Now, I could always check this on my calculator. If I went to my calculator and did log of 25, I get approximately our answer. It's going to be different because it's an exact value and it's rounded. But it's a good way to check. And then lastly, let's take a look at log of 8,000. This can be rewritten as log of 8 times 10 to the third. So I have two different rules happening here. Log 8 plus log 10 cubed, but then that cubed or that exponent comes to the front. So log 8 plus 3 log 10. According to my table, log 8 is 0.9031 and log 10 is 1. When we evaluate that using our calculator, you should get, you should get 3.9031. And that's how you use log properties to find exact values using a table.